Welcome, and nice that you were with us in this talk about trains, about digitalization, and about cloud native, of course. We are from Rail Cargo Group. This is part of ÖBB, and we are transporting goods. My name is Marita. I really love trains, so I moved to Vienna, started at ÖBB, and now I can travel Europe with this great connections we have from here, like night trains going to Rome. And yeah, also they hired me because of my expertise in software engineering, and I'm the solution architect now for this digitalization platform called Mike. And I have also Dimi with me.
Oh, I'm since the beginning of the project, so supporting it, and I like it pretty much.
Yes. Did you know that transporting goods on a rail is 6 times less CO2 carbon than on a truck? That's quite cool. So what is rail cargo? This is a really, really complex business, what I learned starting this year here. Because, of course, the tracks don't go from where it should be picked up to a warehouse, but sometimes you need a truck to pick it up from a warehouse, or you need to go from a boat to a harbor and then put it on a train, and the other first mile and last miles on both sides you have this problem. And we deliver 1,200 trains a day. And even if you have everything on this one train, it might be that each wagon of this train is belonging to a different customer, and they need to go to a different destination. And therefore, you need to have this process in the beginning where you put all the wagons in the right order in the right train. Again, you have this possibility to also transport trucks on a train. It's the picture with the green background. You can also transport whole containers, like you might know from trucks. It's really a big diversity of things you can transport. We deliver this we operate our trains in 14 different countries, and we also provide transportations in 18 countries. So all these reddish areas are supported by rail cargo, and it's the second biggest cargo transportation thing in Europe. So Deutsche Bahn, of course, is bigger, but then it's right in Austria. It's really complex because you can imagine we have tunnels, so the goods must fit into this tunnel. We have bridges. There might be some limitations on how heavy can stuff be, because we're talking about thousands of tons of stuff. And sometimes it's maybe very steep. Then you need a second train that's supporting the brakings, that you don't rush into the lake that is at the bottom. So there are a lot of different scenarios, and I'm a technical person. I'm not into this business, but even what I understood is crazy. So you can imagine. One hint, so you might know this history in rollback, which is a really nice thing. Doesn't work if you have something done wrong in the train movement. And if you think, now I know what to digitalize, how the process should look like, then something like Emil is coming up and the whole thing stops and you need to figure this out. So yeah, the unknown unknowns are quite big as well. No history in rollback here, unfortunately. So how did it all started? The current, or the former current, both of the logistic chain is very analog. So people putting papers to the next station, getting a sheet, long Excel sheets, you can imagine, or they fax stuff still. They call people because they worked there for 30 years. They know if this and that good is in this and that container, that might cause problems in the next station. But a lot of those people go into retirement. That's a problem. So we need more processes and more visibility into the data. So the idea is to have the central platform that supports all of this, where we can collect the data, we can provide data already to other stations where it might come up in the future, prepare stuff, be better prepared for the next steps. So this is the whole idea on the digitalization platform from a business perspective. And the technical solution for this is called Mike. This was created or started in 2019 and should be the digital heart and brain of this whole endeavor. this is how Mike looks. This is one of the solutions we have there. It's called Transport Network, and it's kind of the Google Maps for transportation. So you can say, I want to have a transport from this place to this other place, and then you get a lot of information like border points, because what I didn't mention earlier, if you cross a border, you might even need a new train because there is a different power supply. You for sure need a different driver because you can only drive in one country with your license and not in another one, all those things. And this solution here helps. So this is one of the mic modules. Okay, so I was asked to talk about Mike in our Cloud Native conference. And of course, the imposter syndrome hit hard because Cloud Native, I think all of you guys know what it is. What is the definition? I did already mention cloud in my master thesis, 2012. So kind of digital native, cloud native, I don't know. I also started my first development on a cloud solution in 2015, and we did everything briefly with microservices, how you should do it. We also considered two-factor apps, so everything like a charm. I also did a talk back then on what failed and why we shouldn't have done it in that way we did. But the real definition of cloud native, I was not so sure. So I looked it up. And to my defense, I also found a screenshot from last year, and the definition was different then. So maybe that's something you can hold me at the positive part. So this is how the definition looks. It's rather short, which was surprising to me. And it mentions things like loosely coupled systems, security, resilience, manageable, sustainable, observable, containers should be there, microservices should be there, immutable infrastructure, serverless, and declarative API. Sounds reasonable? So have a look how Mike looks. So let's have a look on our architecture. So we are an event-based system. The core center of our solution is an event bus. This event bus provides messages to all our services. So we have specific modules like ordering, tracking, or fleet management. So we have different containers, wagons, which we also manage. And we also have platform services, we call them, like the user management or a notification office, so that users of the UI can receive notifications they're interested in. And as we have a lot of legacy still, we also have adapters that connect to the legacy world. On the front-end side, we provide a container from a platform perspective that serves micro front-ends, and they also, of course, belong to the back-end services. It's pretty simple. So we also have cross-functional requirements, which we solve by serving libraries. That gives us the possibility to align on logging, authentication, and all those stuff, which is important. If we check our definition, okay, microservices check, loosely coupled with the event bus check, and it's observable because we make sure with our instrumentation that everything is there, but we need to check on later. Okay, then let's have a look on how our solution is served to the cloud. So how does the development process look like? So the core is our GitOps approach. We have the different repositories, for example, ordering, what we just said, where we can order a new transport. There's a Git repository with CI, it's built and tested. Personally take care, there's a lot of quality gates in there, quality gates as well. And then they land in the container registry in our GitOps repositories with the Terraform stuff in there. Make sure that the pods get deployed in our AKS, Kubernetes cluster, we use Azure. And we also have SaaS solutions there for databases, for the event bus, and so on. Checking again on the definition. So we have containers, our pods are running there everywhere. We have immutable infrastructure. Of course, we don't log into servers and mutate them, but we just deploy a new container. We have declarative API because we have infrastructure as code. Everything is defined there. And we also have some serverless stuff where we make sense to not develop our own solution. There was much more stuff on this page, so maybe we'll have a look on one of our services to get a bit deeper into the technical perspective.
So yeah, well, again, welcome everyone from my side. As we promised that we will look into some parts of the platform. I would like to start some kind of introduction into something I called customer perspective. So you may be familiar with that one. We will look into some of the challenges we faced during the whole digital journey, which is still performing, by the way. So you may be, or it may sound familiar, you have a customer, like you have a web shop, or you have something where you sell goods, like Cargo is selling like tracks and transports and so on, stuff. And the customer simply asks, I would like to place an order to like transport things from A to B. Pretty obvious, right? It's very easy. So there's like an ordering service, which may be told the customer by the operators of the platform or from the support, whatever, where the customer simply needs to click on and then he can place his order. Well, it's not always the thing that if you expect something that it's exactly the case, right? And if the customer looks into what he got told to do and there's actually no ordering service right now, what to do right now? So the customer is confused at this moment, right? So, but not only the customer, the operator is confused too at the end. So, and it may even result in something like this, where everyone is asking the other ones, why is it not working? Because actually it was expected to work, as it's one of the core things should be present at the platform, because otherwise you cannot sell something, right? So before going into some more technical details, let's talk about kubectl. You may be familiar if you run your stuff on Kubernetes and you deploy your containers, your services on Kubernetes, and now you usually would like to test out the API if it's working correctly with all of the flags set. Like, for example, Reinhard mentioned at the first session today, it's a bit complicated in configuration, right? So we are using, by the way, like GraphQL. So, but there are REST APIs, whatever, and simply imagining testing the backend by calling some endpoint, whatever, and we receive some results. By receiving these results and looking into this, you see we have actually only like the developer perspective from that, right? Still, and I mentioned some customer perspective. So what we actually would like to achieve is to have something like this. So where we have the real customer performing something and the developer being able to somehow reproduce this. Of course, there are like solutions like observability, frameworks and everything, like mentioned before. But it's often the case that if you see some results from something, it already happened, right? And if you have an issue, it may be that complicated that you need to like debug it in exact this moment when this issue happens. So, would be pretty nice if you could reproduce this somehow, right? So before moving into the demo, let's talk about identity. Like I mentioned, we would like to catch the session or the bug happening when the customer is calling the page or whatever. But you can imagine that the customer is not actively waiting for you, right, to open your debugger, configure everything, and then like, okay, I'm ready. I try to do the order right now or whatever. That's why many platforms, or it's one of the common approach I would claim, you may have an identity provider, which is actually for authenticating the users and providing some kind of identity. And like here, we have the platform to the right. And we have a trust connection between the identity provider and the platform by simply using OpenID Connect and JOT tokens. So what we expect is that we have a valid signature and we can use this JOT token everywhere across our platform with all of the microservices at the end. And additionally, we may expect that we have some user data present as the token is signed, so the same data is signed. And we can simply like reuse the information stored in the token. Some of the information is mandatory, like some claims are mandatory, for example. And yeah, that's it. Looks pretty good, right? So we can work with that. But actually, what may happen is if you rely too much on an identity provider, especially if you're not developing it. By the way, it happened to us, where we, at the beginning of the project, relied too much on the identity provider, and then we had the issue by switching to another provider, so that it resulted in some kind of a vendor lock, because you cannot expect the vendor providers to implement your business logic at the end, right? And additionally, you may lose the authority of your own data. Like, imagine, maybe you have seen it somewhere. Usually, people connect like an Active Directory to an identity provider like Keycloak or whatever, and then they provide this information using the JOT tokens, like millions of groups in a JOT token, which may result into something like this. So, like putting an embedded database of the user data into the JOT token, which makes less sense, as you need to maybe adjust your infrastructure parts, like increasing headers, like you have increased amount of or increased numbers of traffic across your infrastructure parts, right? And it may even be slower at the end. So that's actually not what we would like to achieve. And on the left, the provider got like the leading position in the whole system. So what we would like to achieve instead is something like this. I would like to have only the minimal required information, the JOT tokens. We could even maybe replace the JOT tokens with some other identity or authentication information later. So, and we would like to get our business logic back into the platform, so not like relying fully on the identity provider at the end, where we have, like if we implement something, for example, authorization parts or whatever, or given groups required to access some services, they should not be like evaluated in the IDP, because IDP has no idea what you're doing on your platform, right, in your business. So the signature is still present, right? So we did not change anything to that. So it's still valid. And we gain back our authority of the data as we are still within our platform and doing stuff after getting the token. So additionally, we move like the leading position or the leading part of this authentication authorization back to the platform. Now to the demo. What I would like to show you right now is how we developed, still developing some core services or core parts of Mike with some of the approaches I mentioned before, and what flexibility it results at, and or what advantage it will show. So I will run Mike locally on my PC. So logging in as my user, Dimi. Mike is like not vendor locked in any way with its core components. Of course, vendor locked to the legacy systems, because you cannot move like ages old system to even this MacBook or whatever. So you need to somehow use those adapters. And but you can simply run the core elements even on the laptop or on any cloud at the end. We are using Kubernetes, so we are fine with that. We'll look into this in a few seconds. So, and now as my user, I have the option to access some modules, so some core elements of Mike. And we see here, I have in my local setup for my local development, of course it will look differently in a production environment, I have two users configured, myself and Marita. And now I would like to somehow try out the approach we discussed before, so like developing in a real system, not like in a test environment, which may be completely different to the end environment, which runs with customer feedback or with connection to customers, right? So let's have a look how to do that. First, just to look, it runs in Kubernetes, which will result more or less the same in a real environment. And we are only interested right now in this user management service. So now I will do this reverse connection to the user management service, but not changing it in any way. So I'm not touching anything on the Kubernetes side. I keep it as it is at the end. So what I would like to do now is simply start the application as you would do this usually, just hitting start button and developing it locally. And just imagine at the same time I performed the login or refresh the page. So, and this results in my user be available in my debugger. So like I catch even the session because I established this connection. So technical details are not that relevant actually. And let's have a look into my user. So that's Dimi's session. Then Dimi has no modules actually assigned, but it still works. This works because of the reason I have a special flag configured to be like a global administrator or like a root user in the platform. So I can see actually everything. And now let's get back to the platform. Now, Marita tells me she would have expected actually with her user to see exactly the same I showed you. And this seems to be not the case, right? You may be familiar of some RFCs covering such things like impersonation. The interesting thing here is, like I described before, we could implement it on the identity provider part, which is, by the way, maybe very individual to each identity provider out there. So what we did, we are not touching anything from the identity part, like we are not exchanging tokens or injecting some stuff, but what we are doing is simply telling the whole platform, it's Dimi. But Dimi would like to see right now, so impersonate Marita, what's wrong. And let's do that. So now I have the view from Marita's perspective. And as you see here, indeed, we do not have exactly the same stuff configured, right? So something is missing here. Let's try to catch this bug. So it will result in exactly the same thing, like hitting the breakpoint. And now I have simply a different session where I can inspect all the values with what is different, so I can identify where I need to do the corrections. Like I have the user from Marita right now. I have the same amount of modules, which is okay. But you see, there's already the flag, Mike admin set to false. Maybe that's the indicator, right? Because I mean, I had it set to true. Let's fix that back. So, back to the platform. And as you can imagine, many times it's already like sufficient to power off and on a system or simply reload the page, right? So let's fix this bug magically by simply refreshing the page. And we see now all of the models got restored or are now available, and the view is exactly the same as my view before. And if we look into the values again, we see that the mic administration configuration is now set to true. Of course, there's a bit more, much more things are happening behind, and it's not like simply reloading the page at the end. But anyways, I spit up. So just to show you some stats, this feature, one of the mostly used one, I guess, went live almost 1 year ago. And you see it got some kind of an increase. And the in a waveform, right? So it's not linearly, because it's actually expected, as you may have some demands at given times, so you introduce new features where no one is familiar with this. If you would have some kind of a linear increase in the usage of this feature, it would maybe result in that everything we are doing is wrong, by the way, because actually, like with any new feature or anything shipping new to the platform, each customer needs more and more attention or more support because nothing works at the end, and it's not the case at the end, right? So we covered some of the points, and you see with what I have shown you, our focus was to focus more on the customer side, to ship like benefit to the customer of using the platform, not like spending time only on somehow figuring out the bugs by writing emails to the customer why something is not working, and even you may be much more confused during that. So that's mainly it, and I will hand over to Marita for the closing part. Thanks.
Maybe one more hint to the microservices approach we are following. Because I personally just have seen it failing, I really want to point out the topic about distributed monolith. And this is an actual real big problem in an environment where you try to digitalize services and processes step by step, take over from legacy systems in a way that you say, okay, we cannot do Big Bang, of course, we need to do it step by step. This is a huge topic, also culture-wise, on how to organize this. And I would like to find out how we did it at Real Cargo in terms of organizational structure. So our digitalization is set up in a way that it supports the DDD approach. So we have product managers for the different domains, for example, assets or customer services. Within these domains, we then have the product owners responsible for different services, like the fleet management or the ordering. And within these services, then we have teams supporting this. So one team might support multiple services, but this is how we did the approach. And with our Scrum, we do Scrum, of course, we do SAFe to align with all of this. So it's not perfect, but I think it's a good approach to make a bit better alignment on how we can include those processes in the development, and make also the organization, which is not a software company for sure, aware on how can this changes be done, get feedback from them after every PI reporting, and these feedback loops. So this is just something I would like to mention in the end, because a lot of this journey also contains cultural changes, not only from the developers who need to learn how GitOps works, but also from the organization itself on how to change in more agile approach. To sum up, we have complex challenges in rail logistics. Hopefully you get a little bit of that. We use cloud-native technologies to support this change, but we also have cultural changes, which are a big part of the story. So, thank you so much.
Thanks.
Hey. Thank you. Very, very interesting story. I was really going very more interested to get even more details, but obviously 30 minutes is too short. Do you have any questions? I see that one question here.
Hi. Thanks for the talk. Just to be clear on that, you're doing some kind of remote debugging on production, right? Or is this just in an evaluation phase?
Most of the time. So we do not run it right now in production. You could actually, and this won't even harm the environment from my point of view. During the last months or even years, this space changed a lot. We used different tools previously. Mainly we develop this way completely, so we do not start like stuff locally in the core services, but we develop in Kubernetes. And many times before features are shipped to production, you can already identify, as we have of course different environments, if there's something wrong or someone is not hitting the right button and so on. And if you ship it already corrected way to the prod, you have less issues later. And on production environment, only the impersonation is mainly used by simply looking in where the customer is struggling, or everyone using the platform actually at the end. And that's it.
Okay, because I would imagine if you do this in production, something like you could mess up data quite easily.
You mean by connecting and reversing to the production environment?
Yes.
Here I simply mirrored it. Most of the time, it's already sufficient to get the real request data, right? Like you have not only the endpoint simply connected to the internet, right? Oh, sorry. you have something in between like load balancers, firewalls, and what the hell they are doing, it may be different, right? Like skipping headers, injecting headers, whatever. And it's somewhere very difficult to reproduce. Of course, you can look into observability systems, but observability systems may not always hit the exact same situation, right? Where you would like to look and exact this moment like I showed.
So it's mirrored in a sense that it's still going to the production system, but also to your local system. Yeah. So that's what I got.
Yeah.
Okay, thank you very much.
You could do both approaches, actually. It depends what you require. But most of the time, I know production environments are very sensitive.
So just for to be in time, so do you have one more last questions? And if you have any other questions, we can still, we're going to hang out later on, so you can still have questions for later on. So do you have a last one last question? Nope. All right. So thank you. Thank you so much.